Hey, my name is Antonia, I'm from Germany and I'm now working at ETH Zurich in Switzerland, where my research focuses on interactive object-level mapping with uncertainty quantification. In mapping, we're using the information from the robot sensors over time to create a representation of the world. These sensors can consist of cameras, but also depth sensors that measure the distance to nearby objects. Based on the map, the robot can then reason about how to achieve a goal, such as, for example, going from one place to another, because the map allows the robot to remember what it has seen so far. But a map is also key to increase the situational awareness of the human operator. One of the fundamental challenges in aerial inspection maintenance is the fact that the aerial robot performs its work at height, while the human operator remains at the ground level. The human operator is therefore entirely dependent on the information from the robot, and this information can be limited in the field of view and hard to interpret. Imagine, for example, the case of a video stream. From a video stream, you can only display a part of the scene, and it is challenging to estimate the distance to nearby objects. Now, based on the map, we can actually extend the operator's field of view and also display additional information on top that we derived from the map. Now, one of the key challenges in building good maps is the fact that the robot's perception of the environment is limited. One reason for this is the imperfection of the robot sensors. Depth sensors, for example, might fail to perceive glass surfaces, which results in wrong distance estimates. But even with perfectly good sensor readings, ambiguities in the scene might remain. Without moving them, it might, for example, be difficult to judge whether objects in the environment are firmly connected or just happen to be located directly next to each other. As humans, we're intuitively aware of situations in which we're unsure about our environment, which lets us act cautiously. To bring the same sense of uncertainty to the robot and the human operator, we are working on modeling uncertainties in the map to indicate how much the provided information can be trusted. Then, as a next step based on the estimated uncertainties, we are working on novel methods to let the robot interact with the world to autonomously reduce the uncertainty about the environment, thereby building even better maps. I hope this video gave you a quick insight into the research that we are working on, and make sure to also check out the videos of the other AESRs.